Here's an explanation for the answer to final exam, question number 40 in Electronics Demystified 2nd edition. If you have the printed book, you'll find it on the bottom of page 425 along with figure exam-7, which I have reproduced here. In this circuit, we have an NPN bipolar transistor, a 9-volt battery which provides the voltage between the emitter and the collector of the transistor, and a 1.5 volt cell which provides bias for the base. Under these conditions, what would we expect to observe? And of course we have a milliammeter here to indicate the current that flows from the emitter through to the collector. Well, it's a good thing that this polarity configuration is what it is, because otherwise we'd likely burn the transistor out. There are no current limiting resistors in this circuit, as you can see. But note the polarity of this cell right here. The polarity puts a negative 1.5 volts on the base, ensuring that this device is going to be cut off, so we're not going to see any current here. The correct answer to this question is A. We would expect to observe cutoff in a circuit like this. And in order to get an idea of what exactly would be going on there, let's go back to chapter 7 and look at the characteristic curve for a bipolar transistor as it relates to amplifier classes. Now that's a little bit later in the book, but this is the final exam. This particular topic was discussed before chapter 7, but this is the final exam. You're supposed to know everything in the whole book and put it to use as one great unified whole. So you can look at this, and anyway, this will provide a little bit of an explanation as to what it looks like in geometrical graphical terms. We have forward bias and we have reverse bias. When you reverse bias a bipolar transistor, as is shown here in the figure from chapter 7, you're going to get the condition of cutoff. The cutoff point is right around zero bias. Actually, it's at a very tiny forward bias, equivalent to the forward breakover voltage of the emitter base junction. But it's practically zero when you're dealing with significant voltages on the collector. You can pretty much consider it to be zero. Anyway, a Class B amplifier operates at cutoff. A Class C amplifier operates past cutoff, that is, with a reverse bias. So what we saw in the previous diagram would be a good indicator of what we might do to set a transistor up as a Class C amplifier. It's going to be cut off because it's going to be biased beyond the cutoff point in the reverse direction. So we're going to observe somewhere along in here, in this part of the characteristic curve, 1.5 volts negative on the base. It'll be somewhere around there. Anyway, once again, the correct answer to this question is A, cutoff.